Greetings everybody, and welcome to example 3 of our series on dot products. So in this problem, what we have is that a football is casting a shadow directly onto the field. If the football was initially thrown with a speed of 50 miles per hour at an angle of 30 degrees to the ground, how fast did the shadow move across the ground? So again, kind of in this case, what we're really thinking is that we have the velocity vector of the football that's heading off in this direction. And what we want to know is how fast is the speed going along the ground. So what we really have then is we're interested in the scalar component of the projection vector of the velocity of the football onto the ground. And so if we know that this football is thrown at an angle of 30 degrees to the ground, we're actually able to write down its velocity vector as being a magnitude of 50 times the cosine of 30 degrees in the horizontal direction and 50 times the sine of 30 degrees in the vertical direction. For the ground, quite naturally, we just have our ground vector of just 1, 0, kind of going in the same direction as the football. So if we're looking for that scalar component, then what we have for the component in the direction of the ground for our velocity vector v is just going to be our g dot v divided by the square root of g dot g. And so in this case, what happens is that our horizontal component, we've got 50 cosine of theta times 1. So 50 times the cosine of theta times 1 plus 0 times the sine of 30 degrees. So, let's put in our angle. Our angle was 30 degrees. And then for the square root of g dot g, we have the square root of 1 squared plus 0 squared. So we just have 1. And so our actual answer then is just going to be 50 times the cosine of 30 degrees, which was going to be root 3 over 2. So our actual real answer is going to be 25 root 3. Now, if we want to round this to 2 decimal places, what we have is a value of 43.30127 miles per hour. So I hope you've enjoyed this video, and I will see you guys in the next problem.